Hello everybody, in this video we're going to continue looking at blockchain and we're going to consider how you can store images permanently, and we'll be looking at IPFS. So this is fairly new to me, so I thought I'd just do a guided tour of how I'm learning it, and what we're about to see is probably me making some errors but also learning how to work with IPFS using Python. So let's begin. Okay, so if you've been following along with this series, and you may see other videos which are quite short and they are to do with creating NFTs, how to make millions using NFTs. I'm trying to concentrate on learning all of the basics and prepare all the groundwork for doing this correctly. When I say doing it correctly, perfect example here is if you upload some NFTs, which are non-fungible tokens, just to recap, they're images which you can then sell the digital rights to. Non-fungible, so it means they're unique and the ownership of them is transferred via the blockchain. And if you're here for some Python code, then just hang in there because we will be getting to that in due course. So obviously Python doesn't live in isolation, so what we need to do is just consider, if you have an NFT collection such as CryptoPunks or CryptoKitties or any of those, where are the images stored? Now, we'll get to this in a minute, where CryptoPunks have had their own solution to this, which was to store them on the chain, but this used an enormous amount of gas fees. Gas fees are basically another word for charges on Ethereum. And if you're unfamiliar with Ethereum, it's another cryptocurrency along with Bitcoin and so on. Right, with all that being said, let's start reading about IPFS. So if you go to ipfs.io, and let's just read what it says. IPFS powers the distributed web. So distributed, much like decentralized, and as you watch more of these videos in this series, you will hear me say that more and more often. Obviously, the whole attraction and the uniqueness of the blockchain is that it's decentralized. It's decentralizing. Nobody's got sole authority, power over the assets. So anyway, IPFS powers the distributed web, a peer-to-peer hypermedia protocol. So you've probably heard of peer-to-peer before, and that's probably been with torrents. And obviously there's nothing wrong with torrents. The only issues with torrents is when you end up with copyright issues, which is another story. So these are designed to preserve and grow humanity's knowledge. So that sounds quite a good ambition. But making the web upgradable, resilient, and more open. So I don't think any of us would object to any of those. So I'm just going to zoom in a bit so we can see it a bit better. The web of tomorrow needs IPFS today. Okay, don't worry, I'm not going to just make a hour-long video of me reading stuff off the screen. We'll get to, I just want to lay the groundwork here, and then we will go and look at how we can interact with IPFS with Python code and actually do something useful. So just have a quick read of this and then we'll crack on. So today's web is inefficient and expensive. Without reading all that, I just want to discuss something called link rot. Basically, it's when you go to look at a page and either the link's broken or the page tries to load all of the images, and instead of getting the image you want, you just get image not found, and you just get a placeholder. That's what happens when you have an image stored on a web server and the web server is no longer accessible. So to summarize this, it's distributed. So there's not many copies of the image, but all of the, if you imagine with torrents, the parts are distributed all over, and there's always more than one copy of those components. So it's like having a jigsaw puzzle, and there's 10 lots of that jigsaw puzzle all just scattered around the internet. So you can always find the 100 pieces that you need. So the average lifespan of a web page is 100 days. I read this earlier and was amazed. I thought it would, be a year or two at least. The medium of our era, i.e. the internet, should not be this fragile. IPFS makes it simple to set up resilient networks for mirroring data. And thanks to content addressing, files stored using IPFS are automatically versioned. So you're never going to get an old out-of-date one, which is good. Today's web is centralized, limiting opportunity. So you may read, if you are new to NFTs and you're thinking about creating your own, where those images are not stored on the blockchain, only the ownership, i.e. the hash of your ID is stored on the blockchain. So the internet has turbocharged innovation by being one of the great equalizers in human history, but increasing consolidation of control, Amazon S3 or Google, threatens that progress. IPFS stays true to the original version of open, flat web by delivering technology to make that vision a reality. So this all sounds pretty good, and it's new to me. So if you have some comments, suggestions, of some pitfalls with using this, then please drop some comments. Otherwise, we're just going to read a bit more of this, and then we will get to installing IPFS, and we'll write some code with it. So hang in there. IPFS powers the creation of diversely resilient networks. So anybody who knows anything about networks, or anybody who's used Facebook, will know that networks can break. So the reason they often break is because a single point of failure. And again, single point of failure is pretty much equivalent, or the same problem, or the same idea as consolidation of control. So this means better connectivity for the developing world during natural disasters, or even just when you're on a flaky coffee shop Wi-Fi. Well, don't go to a coffee shop, brew your own. So join the future of the web right now. Okay, IPFS. So IPFS stands for InterPlanetary File System. So it's kind of, at the moment, you can access it by using a special browser which detects if you start a URL with IPFS. So you can see here, add IPFS to your browser. And then there's bits here for developers. So to start with, we will just try and install IPFS and get it working with a browser extension, and also try and get it working with the CLI interface. For those of you who are interested in the kind of the under the bonnet nitty gritty detail, when you add a file to IPFS, your file is split into smaller chunks, kind of like I was saying with the jigsaw puzzle analogy, which I don't know if is entirely correct, but cryptographically hashed. So again, hash is given a unique fingerprint called a content identifier, CID. This CID acts as a permanent record of your file as it exists at that point in time. When other nodes look up your file, they ask their peer nodes who's storing the content referenced by the file's CID. It's a bit like a router looking up an IP address. When they view or download your file, they cache a copy and become another provider of your content until their cache is cleared. So yeah, very much like torrents. A node can pin content in order to keep and provide it forever, or discard content that hasn't used in a while to save space. This means each node in the network stores only content it is interested in, plus some indexing information that helps figure out which node is storing what. Yeah, a bit like a if you compare it to an IP network, then that would be a routing table. If you add a new version of your file to IPFS, its cryptographic hash is different, so it gets a new CID. This means files stored on IPFS are resistant to tampering and censorship. Okay, so if like a hacker or somebody just tried to put on a new image, that wouldn't affect your content. So if you'd made an NFT of, say, a cartoon dolphin, and then somebody came along and replaced it with I don't know, skull and crossbones, the original file of the dolphin would still be presented to anybody who was trying to load it because they were still using the old CID. However, this doesn't mean you need to remember a long string of CIDs. IPFS can find the latest version of your file using IPNS. Decentralized naming system and DNS link can be used to map CIDs to human-readable DNS names. So yeah, lots of parallels to HTTPS and IP, normal IP network. Take a closer look. So want to dig in, check out the docs, explore protest school, read the white paper. Let's just scroll down. This was the bit I wanted to look at. Blockchain developers. IPFS content addressing enables you to store large files off-chain and put immutable. So immutable, if you've studied Python and you know about tuples, you'll know a tuple is immutable, so which means it's not changeable. Permanent links in transactions, timestamping, and securing content without having to put the data itself on a chain. Now, if you read about CryptoPunks, they have actually put it on chain, but they're probably a bit of an anomaly because they were the first and they made so much money they could afford to put it on the chain. But so what this is doing is it's storing basically a reference. So the blockchain storing a reference to an IPFS CID. So if you buy an NFT that's on the block, that's stored on the blockchain, then the NFT is actually just a reference to the image, and the image is actually stored on the IPFS. Who's already using IPFS? Explore the ecosystem. View the ecosystem directory. Wow, let's have a look. I'm probably not quite. MetaMask. Okay, I've heard of MetaMask. Some of these companies are just so new, and they're just more and more every day. It's like the gold rush. NFT Storage. That's Opera browser. I just saw that as well. Yeah, NFT Storage. That is what I wanted to get to next, actually, because like the retro font. That reminds me of my early days using a Mac at college. Free decentralized storage and bandwidth for NFTs on IPFS and Filecoin. Get started. NFT Storage is a brand new service built specifically for storing off-chain NFT data. So yeah, we will get to the Python bit in a minute, I promise. In the meantime, if you're bored and you want to click something because you've got ADHD, just click to subscribe. Right, so to learn more about the importance of content addressing, check out this page on NFT School. We might come back and have a look at that. So you note there they've shown Ethereum, and I don't believe that you have to use Ethereum. You can use any digital currency that supports, I believe, don't quote me on that. So what have we got? About, store, retrieve. Okay, so store. So upload your data and you'll receive an IPFS hash of the CID, the content ID. We're not worried about Filecoin at the moment. Filecoin provides long-term storage for the data, ensuring that if NFT storage is attacked or taken down, the NFT data persists. That's good. Optionally, you can provide additional redundancy by running your own IPFS node and pinning the CIDs of content uploaded and NFT storage. Alternatively, you can use an additional pinning service for redundancy. NFT storage already does this when it backs things up to Pinata, or was it Pinata? Obviously, it's not got the is it a circumflex or the tilde over the end? So it's probably just called Pinata. Doing this is not necessarily, but might be of interest for users looking to be in full control of their data and its availability. So if you've not looked up Pinata, let's just have a look at Pinata. Yeah, so Pinata with the is a paper thing that anyway. Pinata. There we go. Pinata, your home for NFT media. Pinata is the simplest way to upload and manage files on IPFS pinning service. So that's why it's pin. See what they did. See what they did with the pin. Your home for NFT media. So try for free. No need for technical experience from here. From day one, Pinata makes file storage easy for everyone, whether it's images, video, 3D files, or an app. Okay. I have followed some tutorials and I've set up a Pinata account, so we'll come back to that. Let's just finish off checking this out, and then we will actually install IPFS. So just check this diagram. So you've got NFT storage, so that's the distributed storage network, which is lots of IPFS servers that talk to don't talk to each other, but they each hold bits of your file, chunks of your file. So the artwork goes into the storage, it goes onto the storage network, so it's distributed all over. You get a content hash, which is basically a name, description that you give it, and the image is the IPFS // and then the hash. NFT data stored by NFT storage can be accessed from the decentralized IPFS network from any pair that has the content. Good. So I think we're getting the hang of this now. So register an NFT storage account so you can create API access keys. I think we'll come back and do that. Create an API access key, note it down. Choose a method to get your NFT data stored. Okay, so we've got, there's a JavaScript library you can use. So it's your API key, token, API key. And that actually, yeah, store. So that method is actually storing it to the NFT or IPFS network. So we'll come back and we will revisit this shortly. Are there any? Let's just that's quite important. Who can access the data I store? So everyone or anyone. So do not store any private or sensitive information in an unencrypted form using NFT storage, because the whole world, and it will probably be very difficult to delete it. If somebody's already made a copy, then you're done for. Size limit 32 gig. NFT school for best practices. Let's just click on that. nftschool.dev. What does it mean to own a piece of the internet? Can you sell a meme to highest bidder in the metaverse? Finally happening. Let's find out together. So I'll come back to the I can't even say it. the generative art side of things, because to be honest, that's the easy bit. And also there are already code. Shortly there will be my code in Python, and there's many tutorials on how to actually generate the art. As long as you've got something like Photoshop and a small piece of code, having now written it myself, it's actually very simple. So the last tutorial I showed, or the one before last, any of my blockchain ones, pretty much they show you how you can, or the last one I believe, it shows you how you can create NFT art. So yeah, I think the logistics of putting it all together and doing the correct steps and making sure that the NFTs are stored properly and always going to be accessible, I think that's very important, because if somebody's paying money or cryptocurrency to buy your artwork, you don't want to be reliant on just Amazon or Google. And not even any disrespecting them, it's just if you've got a free account and you hit your limit on bandwidth or storage, then Amazon or Google might still be up in 100 years time, but if you don't keep an eye on your file storage and your bandwidth usage, then the poor person who spends thousands of dollars to buy your artwork, they might just be seeing image not found. So anyway, let's just do NFT. This looks good. You got NFT basics, first steps tutorial, and minting service tutorial. Let's start from the start then, shall we? Blockchain. What makes it non-fungible? Obviously the blockchain and the unique identifier. Oh, it's not enough, so yeah, so once an NFT has been stored, it becomes part of the canonical history of the blockchain. So it's stored on the blockchain forever and it can't be modified. Once a block's on the blockchain, that's it forever, really. As new blocks get added, so with Bitcoin, it's every 10 minutes. I can't remember what it is with Ethereum. Is it 7 minutes? Pretty much within a few minutes, it's effectively impossible to change the history. So it's there forever, and there's permanent copies on the ledger of your transaction and your ownership of the currency, not the currency, the NFT, the piece of art that you want to buy. By contrast, traditional web is famously impermanent and dynamic. A web server may serve many different content based on, for example, the time of day or geolocation of a visitor's IP address. Anyone who's been frustrated by an outdated link can testify content disappears from the web nearly as often as it arrives. So yeah, a bit of a mention of CryptoPunks. So if you're new to all this, then just have a look at CryptoPunks and read about them. Hopefully that will give you enough, spark your interest or motivation or your creativity to then delve into NFTs, which is obviously what I'm doing. I'm attempting to do this from a coding point of view rather than a creativity point of view, although some might argue that coding is creative. So anyway, looking ahead, we're still in the early days of NFT. The best way to predict the future is implement it itself. Okay, wise words. So content addressing persistence, designing a minting app. Minting service tutorial. I just want to read this because this might actually building a minting service. So in this tutorial, this looks good. Okay, so they're talking about the Ethereum test net, which I've already experimented with slightly. I'm more interested in this. In this tutorial, you'll go to creating a freshly minted NFT token and storing it on IPFS and Filecoin using NFT. Okay. Hopefully by now you're kind of seeing why IPFS is important. There are a few reasons why traditional HTTP links aren't a great fit for the demands of NFTs. There we see, as long as the owner pays their server bills. There's no guarantee that the content of that JPEG is the same as when it was created. Okay. Content addressing, content identifier, the CID. Yeah, right. So with the IPFS, instead of HTTPS in the browser, you will put IPFS. That's if you want to view it in your browser, which you don't really need to because something like OpenSea or whatever kind of window into the blockchain you use will actually display it for you. Right, getting set up. To help explain how NFTs and IPFS work together, we created an example decentralized web app, or DApp. So if you've not heard of DApps yet, remember where you heard it. No, DApp is digital app. To be honest, the app to me makes me kind of glaze over quite often because if you've got an Android phone and you go on Google Store, to me, app means you get an annoying advert every time you use an app. And if you use Apple, then probably if you download an app, then you have to pay several dollars each time just for the privilege. Anyway, the Scaffold ETH framework is batteries included boilerplate with all kinds of helpful comments and integrations, some of which we won't cover at all in this guide. However, once you've followed this tutorial, you can dig deeper into Scaffold-ETH. So ETH means Ethereum, not Ethernet. Prerequisites. You'll need Git, Node.js, and Yarn. Okay, I'm not going to do all this because I don't really want to go down the Node.js avenue. Let's just see if we can observe what they're doing and just grasp the overall concept, and then we'll look at it. We'll come back and we'll install IPFS on using we'll install it and then we'll come back and then we'll attempt to work with IPFS using Python. So what have we got here? Clone, it's basically deploy, something called an NFT minter. Okay, so eventually you get a web page with an example, and yeah, it's kind of simulating where you have to add some funds. So when you get the fake ether or the fake ETH. So a fee on Ethereum is actually a small chunk of Ethereum currency, which they call gas, which is charged by miners for operation that make a change to the. So whenever you're actually updating the blockchain, there's a fee. That's just how it is. You're paying money towards the miners who are doing some expensive calculations, expensive in terms of computing power, and inexpensive to, well, depends what you call expensive, a few cents or maybe $1 or $2, I don't know. Yeah, so you basically get some play money from the Ethereum faucet. You use MetaMask just to load the app so that you can pay with the play money. You get an API key for the NFT storage. Here we go. So to mint an NFT in our example, all you need is select a file, give it a name and an optional description, and hit the mint button. So what it's doing really is you're giving your file a name. So it's cartoon dolphin. The description is my first NFT example. And then you're hitting mint, which is basically submit, which is then forming a transaction on the blockchain, and it's sending the gas fee, which is the Ethereum. If you know Bitcoin, it's like a Satoshi is a very small amount of, it's a bit like dollars and cents or pounds and pence. So you're just submitting a very small bit of currency of yours to pay for the blockchain transaction. And then once it's done, it mints it. So minting is really just adding the URI, storing the IPFS URI is being stored on the blockchain, and you're just paying a small amount for that. So far we've minted an NFT, added it to Ethereum, and hosted it on IPFS. Now we're going to dive in exactly what the contract does and why. We're also going to explore IPFS side of things and how the NFT itself is stored. Okay, so the NFT mint a smart contract. Right, I'm not going to go into all that because although I'm familiar with it, I don't know enough to try and be knowledgeable about it. No, this contract's not production ready. It doesn't include access controls to limit which accounts are available to call the mint token. Access control patterns that are available. Consider which should apply. If anybody knows about firewalls, access control rears its ugly head again. So I think even though this is a JavaScript example, hopefully you've got the idea that you create a image, piece of artwork, then you add your name or the name of the file, the description, and then you pay a small amount of digital currency when you're ready to mint it. Minting it is when you add the ID to the blockchain and forever make it permanent. So we're getting into all the contract stuff here, so that's getting a little bit lazy minting. I don't know what that is. Minting just in time at the moment of purchase is often called lazy minting. Oh, so it lowers the barrier to entry for NFT creators by making it possible to create NFTs without any upfront costs. Okay, so lazy minting means that you don't actually have to mint it until somebody buys it. Right, okay, so I think it's probably time to get our hands dirty and attempt to install IPFS, because I think we'll come back to the kind of the minting and the contract side of things. I think that's quite a big topic to explore in the future. So let's now look at IPFS and how to install it. Okay, so back on the ipfs.io site. So let's go for some installation. I think we'll go for command line install to start with. Command line quick start. Command line savvy, you just want to get up and running. Yeah, let's do that. If you've not yet installed Go IPFS, follow the install instructions. Okay. System requirements, official distributions. I'm on Windows today because of some recent screen flickering and sound issues using Linux, but okay, let's do the dreaded Windows install, much against. Download the Windows. So just bear with me on this. I know I know some of you use Windows, so I'm not going to alienate some of my viewers. Let's bring this across here. Make the font much bigger. There we go. I wish Windows had the same thing as Linux, where you do the always on top for a window, but never mind. CD tilde backslash. See, this is, why is this not working? This is going to be some stupid Windows, right. I'm going to pause it. I'm going to swear a lot, and then I'm going to come back with Linux. Right, so we're on Windows SL subsystem for Linux, whatever. Let's go. So let's get that. Okay, downloaded. Unzip and move the file somewhere handy. Ah, sorry, we're no longer on, apologies. We're no longer on Windows, are we? Right, let's go for this. Okay, so unzip the file. Tar. Move into the ipfs. Fine. Sudo bash install sh. No, sorry. Too hasty. So we've moved it into local bin. There we go. Test that ipfs has installed correctly. ipfs version 0.10.0. Yeah, that's good. Next steps. Now you've got ipfs node installed, you can start building applications and services on top of the network. Check out the command line quick start guide and jump straight into initialize repository section. Initialize the repository. ipfs stores all its settings and internal data in a directory called the repository. Before using ipfs for the first time, you'll need to initialize the repository with the ipfs-init command. Okay. Be careful with sudo on Unix platforms, including macOS. If you run sudo ipfs-init, the repository will be created for the root user instead of the local user account. ipfs doesn't need root privileges, so it's best to run all ipfs commands as a regular user. That makes sense. ipfs-init. ipfs-init. Okay, so we've got what they say there. Good. If you're running on a server in a data center, you should initialize ipfs with the server profile. Doing so will prevent ipfs from creating a lot of data center internal traffic trying to discover local nodes. Well, I'm not running in a data center, so I'm going to skip over that. Okay, there are a whole host of other configuration options you may want to set. Check the full reference for more. I don't think that would make a very good video, so we'll skip over that. The hash peer identity is your node's ID and will be different from the one shown in the above output. Other nodes on the network use it to find and connect to you. You can run ipfs-ID to get to at any time to get it again if you need it. Let's just try that. There we go. So that's our ID. That's the ID of our node. So the ID, public key, addresses, agent version, protocols null. So far, so good. So the whole point of this is to set up and run an IPFS node on our computer. So now try running the command suggested to you in the output of IPFS init, the one that looks like ipfs-cat ipfs hash readme. So what they suggested to us here, to get started, enter, and then just slightly gone off the edge because I made the font bigger for you to read it. There we go. So if we copy and paste that, copy. Is this not working? Oh. If I get some more money sometime soon, I'm going to just buy a much better PC to put. This is annoying. I'm going to buy a much better PC and put Linux on it, hopefully with a better screen display adapter. There's no point putting one on my current PC because it's about 8 years old, so I don't even know if it would be of much benefit. Okay, you just have to press enter. Slightly embarrassing. Okay, so now ipfs-cat, and then I've basically just copied that from there. And is anything happening? What's going on? There we go. Okay, so hello and welcome to, let's just make that bigger. Hello and welcome to IPFS. If you're seeing this, you've successfully installed IPFS and are now interfacing with the ipfs Merkle DAG. If you remember from one of my earlier blockchain videos, or if you've studied blockchain, Merkle trees are what kind of store the hash of this hashes below it, a bit like a pyramid. This is alpha software. Use at your own discretion. Much is missing or lacking polish. Okay. If I was a better coder, I would offer to contribute, but I don't think I'm quite good enough for that just yet. So anyway, what's next? You can explore other objects in the repository, in particular the quick start directory, which shows example commands to try. No such file or directory. Oh, let's try this. No? Okay. So we want ipfs-cat ipfs / and then do we need to use our own QMY? Yeah, so we need to use our own hash, which was this. Put that on the end here. I'm really not enjoying this Windows Linux thing. Then was it quick start? Yeah. Hey, there we go. So let's go back up and see what happened here. So whatever your hash, you will have a unique hash different to this when you try and run it on yours. This is a set of short examples with minimal explanation. It is meant as a quick start. So add a file to ipfs, echo hello world, output hello ipfs, add hello. View it, so use cat, make a directory, so it's all standard kind of bash, ls, cat, references, get, ipfs get, put the hash, then -o, then -2, and then you look at the differences between the old and the new. Network, so you can look at the peers, ipfs ID, we already looked at that to get our own node ID. ipfs mount uses finicky. ipfs version commands update, blah blah blah. Web user interface, video images. I wonder if that web UI actually works. Let's try that, just out of curiosity. No. Oh, connection refused. I'm just gonna try the other. What browser is this? I can't even remember if this is Chrome or this is Chrome. Let's try Firefox then. Just bear with me. I don't know. Let's go for paste and go. I think we'll get the same result. We might just get a more informative error message. Yeah. Firewall or proxy. I don't know if that's a Windows thing or if that's right. I've had enough of this. Let's try and install it on the Raspberry Pi. So Pi, it's lit up. I've got a light on the little Raspberry Pi 4 down there. So PA55WORD. Yeah, I remembered it. Don't do that at home, kids. Right, where were we? Anyone remember? I think we were here, weren't we? So let's go back up and start. Well, not start this. I'll run through this quickly. So I'm hoping I can copy and paste from. This probably won't work actually because it says AMD 64. Let's see if this works, shall we? So far, so good. Tar, so we extracting it. So far, so good. Go to. So I'm so reluctant to type. I really need to go back to my typing lessons. ipfs version. What did we not do? We didn't do the bash install command. Sorry, I was trying to rush this because we've already done it once. Cannot execute binary file exec format error. We could compile manually, maybe. Now that you've got ipfs installed, you can start build. Right, let's go and see if we can go ipfs. Right. Install ipfs on Raspberry Pi. Okay. In this tutorial, I will use a useful script created by Claudio Bisotto, valid for the versions of Raspberry Pi 1, 2, 3, 4. I can confirm it works. I don't recommend installing Raspberry Pi Zero. Cool. Right, let's go for this then. Let's change back to home directory first. So cd home. All right, git clone. Let's get Claudio's version. Change there. Install. Yeah, update it because we don't know if that old one was a AMD 64. After that's installed, to verify everything went well, we queried a daemon asking for a list of nodes which we are connected. So we do ipfs swarm peers. Oh, someone else has the lock. Okay. Oh, ipfs init. Oh, the daemon is running. Please stop it. Please stop it to run this command. Use ipfs init help. ipfs init help. ipfs. There we go. So if we do kill ps 10851. Yes, arguments must be. All right, 953. Oh yeah, can't kill that one. That's grepping for it. Right, so let's try and run it again then. So it's IPFS in it. Daemon is running. Stop it, run this command, use IPFS. Right, be back in a second, just bear with. Okay, so you didn't miss too much. All I did was I rebooted the machine and then came back on and I just did IPFS in it. So um, as per the instructions. Let's go back to this tutorial. So if you remember, just to recap, how to install ipfs on Raspberry Pi. And so at this point, we've installed ipfs. To verify everything went well, we queried a daemon asking for the list of nodes to which we are connected. Okay, this section must be run in online mode. Try running ipfs daemon first. Wow, so we're announcing ourselves to all of these, to all these other hosts on the network. Daemon is ready. Okay. So now I wonder if this might work. No, let's go over here. No, still firewall problems. Okay. So I'm going to open up another terminal. Yeah, Word. Okay, and let's go back. And now we'll try swarm peers. There we go. So we have got a load of peers to our IPFS interplanetary file system. I think that's time probably to have a breather. And yeah, we'll resume in the next video and we will look at actually transferring. I think it's probably enough for this video. In the next video, we'll look at how we can transfer files to IPFS using Python and using, actually before we ride off into the sunset, let's just see what that will entail. So Python API for IPFS. Well, before we go, I might just try and do a little bit of command line test on this. Pip install. So if you go to the usual Python package installer, pip install, and then it's ipfs-api. So if you check out IPFS and the API command reference for more information on the IPFS API, install it with pip base use case requires running a running instance of IPFS daemon. So let's move that out of the way. I'm just going to make this full screen now because the first instance of the Pi is for this is just the daemon running, so we don't want to upset that. Let's just do clear, and we'll do pip install. This was written in 2016. So although obviously NFTs are a very new and shiny thing, this is 5 years old. Right, so here we go, Python fans. Let's go for it. So imports. I'll just show you where I'm getting this from. I'm just getting this from the project page. Import IPFS capital API. Helps if you start Python first. Right. Good, no errors. So then we say API equals, so basically we create a client instance and set it to our variable of API. Good. And then we create API. Okay, we want to create something called test.txt that we then add. Yeah, thought that might happen. So we need a test file. So let's just go and have a quick look at, sorry, I'll bring this back over here. We need to look at project homepage. What we need to do is actually create a correct format of test file to actually experiment with. Let's just go up here and look at his examples. Test. Oh, that was just the actual tests for this. For real-world scripts, you can reuse TCP connections using a context manager or managing. If you know about Python 3.10, you'll know that you can have multiple contexts now. Client ID. Right, I think I need to come back and read more of this and learn a bit more of this before I try and to carry on doing a video on this because yeah, I think this is probably a good point to finish this video. So what we've actually done, just to summarize, let's come back to my original kind of list of things to look at in this video. So blockchain we've discussed with how using the blockchain for NFTs makes them immutable. So once after, I think what was it? It said virtually impossible for them to be modified to the images. So ipfs, which is what we've just been looking at, and Python, which we've just been briefly looking at. So yeah, in the next video, what we'll actually do is we will go further with the ipfs code, and we will look to create a file, upload it using the API, and inspect it, check it, modify it, and so on. So hopefully this has whetted your appetite for ipfs, and I think the general consensus is that if you are going to create NFTs, then you need to store them using ipfs, which is InterPlanetary File System, wasn't it? If you want to yeah, if you want to read about it, ipfs.io, and I wonder what's on the blog. Yeah, that's updated very recently. So hackathon, decentralizing the internet's roots, decentralized. So yeah, if you're new to any of this, then I'd encourage you to come here, ipfs.io. I say if you've got Windows, Linux, Raspberry Pi, even, you can install the command line version. Desktop version. Okay, you get a nice dashboard as well. You can see how many hosts, how many peers you've discovered, network traffic. Start your node system up from Mac/Windows. Okay, so and Ubuntu. API and CLI, that's what we've just been kind of looking at. Go ipfs even. Yeah, so in the next video, we will come back and I will read more about how to use the ipfs Python API wrapper. So until the next time, thank you for watching. Bit of a long video. Hopefully it's interesting, and hopefully even if you've just fast forwarded or watched it on 1.5 speed or whatever, then you've learned something, hopefully, and it'll be back in the next one. Thanks for watching.